So today we'll discuss one concept, exception handling in Java. Okay, so exception handling in Java. So basically, exception is an event which will cause program termination. So actually in the programming languages, error is different, exception is different. Okay, so both are not same. So error means we have a syntax error, we have a logical error. But exception is not comes under this. Exception is totally different than error. But here, what is an exception? Exception is an event which will cause program termination, So when the exception will come, this is a user mistake, basically. So before understanding exception, let us try to understand what is an error and how many types of errors are there. So we have two kinds of errors, syntax errors, and second thing is logical errors, syntax errors, logical error. So what is syntax error? Suppose while writing your program, if you miss some semicolon or if you miss some curly brace, and if you use lowercase character instead of uppercase character, they're all syntax errors. That means if you're not following any Java syntax while writing your program, it will give you syntax errors. Okay, syntax error is a purely programming related errors. If you're not following Java syntaxes properly, you will get a syntax errors. And we can easily notify them also. So when you're writing a program in your Eclipse, it will clearly notify you with red color line. So there all comes under syntax errors, programming mistakes. Second is logical error. So logical error means the program will execute, but output we are expecting is not correct. If you have a syntax error in your program will execute. Program you cannot execute. If you have a syntax errors in your program, you cannot execute first of all. But if you have a logical error in your program, you can execute your program, but the output or result is incorrect or inaccurate. That's called logical error. For example, if you write a program for adding two numbers, let us say you have provided two inputs, let's say 2 and 5. So what is an output you're expecting is 5. But instead of 5, if you are getting -5 or something else, that is a logical error. So that is a major difference between syntax error and logical error. So these two are related to programming errors, purely developer mistakes. At the time of developing or writing a program, we do mistakes. So syntax and logical errors comes under this category. Now, what is an exception? Exception is not an error. Exception gives when the user provided some invalid input to the program. It is totally user mistake. Syntax and logical errors comes because of development mistakes. Exceptions comes because of user mistakes. Okay, for example, let me explain what is exception here. So normally when you write your program, execution will happen top to bottom. Let's say I have written multiple programs like this. Okay. So how execution will happen? Execution will happen line by line, step by step execution will happen. Suppose somewhere in the program, you have provided some input here, some input value, or you have assigned some value. And if the input is not correct, or if the input is not incorrect, okay, then what will happen is this input is using by some other statement, right? So that will throw the exception. That will throw the exception when the input is invalid or input is incorrect. Then the statement which is using this input value will throw the exception. Because of this exception, what happens? Rest of the lines will not be executed. Rest of the code or rest of the program will not be executed. So as soon as you get an exception, the code will not be executed. The program will immediately terminate, or the program will be terminated by this exception. So that exception will throw if your user is provided an invalid input to the program, or the user is provided some incorrect input or not appropriate input to the program, then the statement will throw the exception. What is the problem with the exception is the program will be terminated immediately. Second thing is rest of the statements will not be executed. This is the problem with the exception. Now, as a developer, what we have to do is we have to identify where exactly the user is providing input. Okay, and if the input is valid, then anyway we'll continue the program without having an exception. And suppose the input is invalid, the statement will throw exception, right? So wherever the input is provided by the user, we will identify those areas and we will put those statements as part of exceptions. That means once the statement throw exception will throw. That is sure. Whenever you pass input invalid, exception will throw. Now we have to handle that exception, go back, and then execute the rest of the statement. So this process is called exception handling process. So whenever the statement throw exception, we will handle that exception and get back and execute the rest of the code. So whenever exception comes, exception will terminate the program by default and it throws exception. And as a development, as per the exception handling, we have to handle that exception. We have to find out which exception it will throw, and we will handle it and go back and execute the rest of the code. This is a process of exception handling. Okay, so exception is what? Exception is an event which will cause program terminated. It is purely user mistake. And errors are development mistake, developer mistakes. Syntax error, logical error. While writing the program, they make some mistakes. They comes under syntax errors and logical errors. Okay, that is a major difference between exception and errors. Right. So now the concept is, okay, because of exception, program is terminated immediately, and then rest of the code is not executed. But in exception handling process, we have to handle that exception. We have to go back and execute the rest of the code. So we'll see how to handle the exception. But first of all, we will see how many types of exceptions are there. Okay, and then when you will get an exceptions, we'll see some examples. And after that, we'll see how to handle the exceptions. Okay. Now, let me clear this. Fine. Now, there are two kinds of exceptions in Java. There are n number of exceptions. We can categorize into mainly two categories. Types of exceptions. One is checked exception. The other one is unchecked exceptions. Checked exceptions, unchecked exceptions. Checked exceptions are nothing but the exceptions which are identified by Java compiler. So we no need to do more work on this because Java compiler itself will easily identify these type of exceptions. It will just intimate you. So where and all the chances are there to get an exception. It is very easy to handle also. So checked exceptions are exceptions which are identified by Java compiler. Interrupted exception, file not found exception, IO exception. These are all different examples. Again, every category, there are n number, hundreds and thousands of exception types are there in Java. And but if you understand how to handle one type of exception, you can easily handle any type of exception. The way of handling the exception is exactly the same. So the checked exceptions are exceptions which are identified by Java compiler, and unchecked exceptions are exceptions which are not identified by Java compiler. So we have to identify this. So we need to work more on this unchecked exceptions because the Java compiler cannot identify. So we have to identify these type of exceptions and we have to handle this. Examples: arithmetic exception, null pointer exception, array index out of bound exception. So these are all different type of exceptions comes under unchecked exceptions. So first of all, we will start with unchecked exceptions because here we have to do more work than checked exceptions. Checked exceptions are very easy to handle because Java compiler will easily identify them. But unchecked exceptions, we have to identify and we have to handle it. Okay, so let me show you one example. We'll start with unchecked exceptions. Okay, now go to our project, create new package. Let's say day 18. So new class, and I'll name it as exceptions demo. Okay, so we'll take main method and also take finish. So just notice here, I'm trying to show you some types of exceptions, and almost different exceptions will come in different aspects, so different scenarios, but we no need to know each and every exception type and each and every scenario, because there are so many hundreds and thousands of scenarios are there, thousands of exceptions are there in Java. So if you just learn 2 or 3 exceptions, the same way we can handle any other type of exceptions. Okay, so first we will see when you will get exception, and if you get exception, what is the problem with that. So I'm writing a simple code here, system.out.println, and here I'm writing simple statement, program is started, and after that I'm writing 2 more statements, program is completed and exited. So here I will write some piece of code, and what I will do is I will take some input from the user. Okay, some number I will ask from the user. So how to take input from the console? By using scanner class, right? I can take one scanner class, scanner sc is equal to new scanner, and here I can say system.in. You can just import the scanner. Okay, now let us take a number from the user. So what I will do is I'll ask one input. I say enter a number, enter a number. And once the user is provided a number, we have to take into a variable. So I'm creating one variable, integer number equal to sc dot next int. I'm taking one integer variable. So after this is taking the input from the user. So once you take the input from the user, I will perform some operation by using this number. So what I will do is I will perform 100 divided by this number. Whatever number the user is provided, I'm dividing this 100 by this number. So this is the operation I have done. Okay. So this is a simple code I have written. Now execute this code, run as Java application. And it is asking for the program is started and enter the number. Now I'm passing some number. Let's say 5 I'm passing. Press enter. So once you provided the enter of 5, so it is saying you got a 20 is an output. So this is written the proper output and program is completed. Then last statements, rest of the statements are successfully executed. Okay, so no problem in this. Everything is went smooth because we provided a valid user, a valid input to the program. Okay, now one more time I'm executing. So this time I will provide, let's say 0. By mistake, I provided 0. When I say enter, now we can see an exception. So exception in thread main. So java.long arithmetic exception divided by 0. So this is the exception name actually, arithmetic exception. Every exception is a predefined class in Java. So this is thrown arithmetic exception. So when you will get this exception, if any number divided by 0 will throw arithmetic exception. If any number divided by 0 will throw arithmetic exception. Okay, so what is a mistake here is user is provided invalid input. User should not provide 0. Other than 0, you can provide any other number. Because user is provided 0 here, when I using that input in this statement, so this statement throw this exception. That's the first thing. Second thing. Okay, because this statement is thrown this exception, these two statements are not executed. That means the program is got terminated exactly in this line number 15. The program is got terminated. So rest of the statements are not executed. So this is the problem of exception. Now my requirement is, even though the statement is thrown exception, still I want to execute the rest of the statements. So how can we do this? once you handle that exception, it is possible. So once we handle that exception, then we can execute the rest of the statements and we can avoid termination of the program immediately. So because of one statement, how can I can stop rest of the statements? I still want to continue with the rest of the statements. Okay, I don't want to terminate the program immediately because of that exception. So we have to handle that exception so that we can execute the rest of the statements and program will not be terminated. So that's the main goal of exception handling. Okay, this is one type of exception we have seen. So what type of exception this is called? Arithmetic exception. Arithmetic exception. Okay, this is example 1. Example 1. Okay, so let us comment this. I'll show you some more. How to handle exception, I will show you in the next example. So this is one example. Now let me show you another example. Example 2. So this time, what I will do is, I will create one array int a equal to new int of 5. Okay, so how much size it is? 5. So total number of positions are allocated are 5. What is the starting index? 0. The last index? 4. 0 to 4 is index values and 5 locations and 5 values I can assign into array. So now what I will do is, I will ask user to provide the value and also in which position I want to add that value. So there are 2 values I want to ask from the user. One is the location where you want to add that number, that is position, and what value you want to add. What is a value I want to add? 2 values I will ask from the user. Okay, so the first thing I will ask for the position. System.out.println, enter position, enter the position. Where exactly you want to insert the value in the array. Enter the position. And what is the starting index here? 0 to 4, right? Between 0 to 4, we can give anything. 5 is not allowed because last index is what? 4. So between 0 to 4, you can provide any position. So that position I will take as an input. Int pos equal to se dot next int. So scanner class object I already created above, so I'm using it. So here in this statement, I'm taking position, in which position I want to add value. Now also I will ask value, which value I want to add in that position. So system.out.println, here I'm asking enter a value. I'm also asking value. Value can be anything. And also I'm taking that value in a variable. Int value equal to se dot next int. So I'm also taking value from the user, also position. Now what I have to do is, this particular value I want to insert in this position in the array because 5 positions are there. So I'm asking position as well as value both. So now we need to take this value and put inside this position. So how can we do this? A of position. Okay, in which position? A of 1, 2, 3, 4 up to 0 to 4 equal to the value. So what this statement will do is, whatever value we have added, that value will be inserted in array in exactly in that position which we provided in this statement. Okay, and after that I will print that value A of position in the same position, whichever value we have added here. I'm just trying to print the value here. So this is simple code I have written. Okay, let's try to execute now. All right, so it is asking for the position 0 to 4. So 0 to 4, we can give any number position because array size is 5. So let's say 1 I am giving. Position is 1. And value also it is asking. I'm say 100. Okay, now it is got printed 100. This is perfectly fine. So program is completed. Program is got executed. So everything is executed fine. Okay, now notice this. So how many positions are there? Only 0 to 4. 0, 1, 2, 3, 4 is allowed. But now what I'm doing, I'm giving 5 here. Okay, so do we have a fifth position in array? In array, do we have a fifth position? No. So this is a user input, right? This is an invalid input. It is not a right input. So when I guess enter, it is asking for the value also. Let me give value called 100. Now just observe, it is trying to enter this value in the fifth position. But in array, we do not have a fifth position. So this will give you array index out of bounds exception. Array index out of bound exception means we are trying to insert a value out of bound. So the maximum upper bound is what? Only 4. But we are trying to insert the value above the 4. So whose mistake it is? It is a user mistake. We have provided 5, but actually 0 to 4 only we have to pass. So this is again user mistake. This will throw array index out of bound exception. This is another type of exception. This particular statement is thrown array index out of bound exception. Okay. So how to handle this? I will show you in the next example. First, we will see different type of exceptions to understand better. Okay. These are all unchecked exceptions because we have to identify them. Right. So array index out of bound exception. So now I'll show you one more type of exception. Example 3. Okay, instead of taking input from the keyboard, I'm directly providing input here. String s equal to welcome. This is also an input, right? But instead of taking from the user, I'm directly keeping the input inside the program itself. So this is also input. Okay, now, or else I can say 1, 2, 3, 4, 5. This is the input, a string. Now I want to convert this into number format. I want to convert the string format to number format. How can we convert? String to number, integer, string to integer. In the last classes, I think in the last class only we discussed. Yes, we have to use wrapper class. What is the target type is integer. So we have to take integer wrapper class. Integer dot parsing of yes. So this will convert integer into a string into integer that I can store in a variable. So here I'm taking one more variable called number. And after that, I'm trying to print this number. So what exactly we have done is we have taken one input here, string. Then we are trying to convert into number. And after that, we are printing the number. So when I execute this, this will work fine. So same thing, program is started, 1, 2, 3, 4, 5 is taken as positive input and then executed. Fine. Instead of this number, if you give alphabets, can we convert this into number? No, we cannot convert. So this will throw exception. Number format exception it will throw. Because this is also user mistake. We have to pass only numbers in the double quotations. Then only we will able to convert into number. If you pass alphabets, we cannot convert into alphabets. So here this statement is thrown exception. Number format exception. So what happens because of this exception? The rest of the statements are not executed and the program is terminated immediately. Like this, you can see so many types of exceptions while writing your program or while writing your automation scripts. Okay. And we should able to handle. So, but how we can notice, how we can identify particular statement is throwing some exception while writing the code, how you will notice it? Simple thumb rule. Wherever the chance is there for providing input or wherever you're taking some input, definitely there is a chance of getting an exception. Okay, for example, if you take these 3 examples, in the first example where you are taking input, here you're expecting the input. So definitely there is a chance of getting some invalid input by the user. And so we need to put this in the exceptions block. So we need to handle here. And if you take the example 2, I'm asking for the position, also I'm asking for the value. So definitely there is a chance of getting an exception because user may provide invalid input or invalid output, invalid input somewhere. So there is a chance of getting an exception. And similarly, if you just take a third example, the third example also, here there is a chance of providing some invalid input. So definitely there is an exception. Okay. There are so many number of exceptions are there like this, and we can handle that exception in the similar way by using try catch block. A null pointer exception also sometimes we will get. Let me take another example. Example 4. Null pointer exception. So null pointer exception you will get whenever you perform operations on null variables. Null is nothing but unknown value. It is not empty, it is not zero. Null is nothing but unknown. Okay, for example, I'm taking one string variable, string s equal to null. Or I can say string s equal to welcome. I'm taking one input here. Okay, when I take string variable, I can apply all kinds of string related methods, right? So what I will do is I'll try to find length of a string, s dot length. Okay, and here you can s dot length I'm trying to print. So I have taken one string as an input, and then I'm trying to find length of a string. So this will give you length of a string 7, perfectly fine. Suppose if you don't have this string, okay, suppose I don't have value in this. Okay, this is empty. This is not unknown actually, this is empty. So this will obviously return 0 because there is no number of characters in a string, obviously returns 0. Okay, but if you say null here, null is nothing but unknown value. Okay, and when you perform operation on the null variables, you will get a null pointer exception. Okay, when I execute as a Java application, now we can see null pointer exception. Not only strings, you can add this null for any type of variables. And when you perform operations on those type of variables, you will get null pointer exception. Because if you don't know the value, first of all, value itself is not there for this variable. How can we operate that variable without having that value, right? So that is the reason it is giving null pointer exception. So this statement will throw null pointer exception. Actually, not this one. This one will throw null pointer exception. Okay. So these are all different type of exceptions you may see while you are writing a program. Okay. Now, the second step is, okay, we understood the problem with the exceptions. We understood two things actually. When you will get an exception. And the second thing is, if you get an exception, what is a problem? So these are the two things we have notified. So whenever you pass invalid input to the program, you will have a chance of getting an exception. That's the first thing. Second thing, once you get an exception, the program is terminating. That is the second thing. So now we cannot control the input because user can provide anything, right? We cannot say we can just intimate the user. So provide the valid username or valid password, but user may provide invalid also. Chances are there. We cannot have any control on that. But once you provided user invalid input, we have to identify that. Accordingly, we have to handle the exception. I will give you a simple real-time scenario where exactly these exceptions are used. Simple example, with this we can understand very easily. Okay, so let us take a simple login scenario. Any application will start with the login screen, right? So let's say you have a login screen. In this, we have to provide username, we have to provide your password. So user and password. Then we click on OK button. Then it will go to the home page. Okay, this is the screen actually, UI. The backend, how exactly it will work, I will show you. So as a user, what I'll do is I will provide username and password. Once you provided username, the username and password will be taken by the program and verify that user password is correct. And after verification, it will allow us to log in. The program will do that. Okay. Suppose if the user is provided invalid username or invalid password or blank username, blank password, that also we will capture. At the time of verification, we will notify the input is not correct. then what will happen? Immediately, the application is not crashing, right? When you provide username and invalid username and password, what will happen normally? It will give you intimation, right? Invalid username, invalid password. You will get some user message, user understandable format message. But your application is not crashing. Your application is still alive. Your application is still working. But it is just intimating you provided some invalid data. So in exception handling works like that. So whenever you take input from the user, validate the data is correct. If the data is not correct, then we will handle that and tell the user back, you have provided invalid input, so please correct it. And because of this is called exception handling. Because of this, what happened? Application will not crash and user will able to provide another input. Okay. So this is a simple example for exception handling. How internally the developers will write the code. So here there is a chance of getting invalid input by the user. This we don't have any control. User can provide any type of input. We don't have control. But as a developer, once you get an input, if it is an invalid data, instead of terminating the program and crashing that application, we will just handle that exception and provide message to the user, like provide valid data like that. So this is example of exception handling. Okay. Now we will see some examples of exception, how to handle the exceptions. So we have seen some examples here. Now we'll see how to handle the exception. And it can be any type of exception. The handling mechanism is same. So if you know how to handle one type of exception, you can handle any type of other exceptions. So we don't need to discuss how to handle each type of exception, because it is exactly the same. How we can handle one type of exception, in the similar fashion, we can also handle all other types of exceptions. Okay. Now let us go and see one more example, how to handle the exceptions. So we understood two things so far. One is when user provided invalid input, there is a chance of getting an exception. Once the exception is occurred, then program will be terminated and rest of the code is not executed. So these things we have understood so far. Now the next step is, suppose if you get an exception, how to handle it? How can we avoid program termination? So let's create a new class and I'll name it as handle exceptions. Handle exception, taking main method. Okay. Now go back to the previous one. I'm just copying one part. Let us say this part. Okay, you can take any type of exception. I'm taking the first example. So here, this is a code. Also, I copy these two statements. Okay, just observe. So this is a code which we have written. If I execute this code and it will ask for the number, and if the number is invalid, so I'm passing 0, invalid number. So this will throw the arithmetic exception. Now the thing is we need to handle that. So here there is a chance of getting an invalid input, right? Where is a chance here? And this will also work fine. The statement will not throw, but the next statement, wherever we are using this input for operation, there exactly the exception comes. So now we know exactly this is a place the user is providing input. So maybe this statement may throw exception if the user is provided invalid input here. So we have notified that. So once you notice this, how to handle that exception is the next step. So to handle that exceptions, we have try and catch block. So whichever statement is throwing exception, we keep that statement in the try block. So inside this, we can keep the statement. Whichever statement is throwing exception, that statement we have to put in the try block. And after closing the try block, immediately we have to start another block called catch block. Inside the catch block, in the catch, we have to put the exception name in this bracket. So what type of exception this statement is thrown? that exception class name we have to specify. For example, if the statement is throwing arithmetic exception, now in the catch, we have to write arithmetic exception like this. Arithmetic exception is a class. So we need to provide some object reference variable also. So this we have to mention. And inside the catch block, you can do whatever you want. Suppose if the statement throw an exception and catch block will handle it. So inside the catch block, what I will tell, I will provide the message to the user. System.out.println, and here I can put, you can print exception statement, exception message, I can print in the console window, or you can provide some information to the user, like you provided some invalid input like that. So in the catch block also, we can write whatever statements we want. So by using try catch block, we can handle exceptions. So let me show you how to handle. Now, which statement is throwing exception? This particular statement is throwing an exception. So I will put this statement in the try block like this and close this. Okay. Suppose if you have a confusion, whether this statement is throwing exception or these statements are throwing exception. If you have a confusion, you can keep all three statements in one try block. You can also keep all three statements in try block, no problem. Because try block is allowed one or multiple statements. If you don't know exactly which statement is throwing exception, you can put a group of statements directly in the try block. Okay. But here I know exactly this particular statement is throwing exception, so that I can put only that statement in the try block, and immediately try block followed by catch block. And catch block, we should have a bracket. Here we need to specify exception type. What is an exception that statement will throw? Arithmetic exception. Suppose if you don't know what exception it will throw, there is another way to handle. Okay, I will show you that. So for now, just assume this particular statement will throw arithmetic exception, that we already know. So that is the reason I'm putting arithmetic exception and give some variable object name. And here, if you want to print the arithmetic exception details in the console window, you can put, or else you can write a simple message for the user like invalid data like this. After that, rest of the code will be continued. So whichever statement is throwing exception, keep that in the try block. And to handle this exception, catch block should be there. So who is handling that exception exactly, try block or catch block? Catch block is catching that exception. And this message will be given to the user, and rest of the code will be as usual executes. Okay, now let us execute. So this try, okay, if exception comes, then only the catch block will execute. If the statement is not thrown any exception, if you provide valid data, right? So then also the statement will execute. If you provide valid data also, the statement will execute. But there is no exception, so catch block will skip automatically. Catch block will not execute. When the catch block will execute, if the statement thrown exception, then catch block will be executed. Okay, so let me show you both the scenarios. When I run the Java application, so now this time I'm passing valid data. So successfully executed, no problem. Now when I execute a Java application, now I'm passing invalid data. Now observe, we haven't get any exception in the console window. Earlier we got arithmetic exception, but this time we haven't get any exception. Instead, the catch block is got executed. In the catch block, the statement is got executed, and rest of the code also successfully executed. Okay, so this is the main advantage of handling exceptions. We can avoid program termination. At the same time, we can also execute rest of the code by handling exception. So this is the only way we can handle exceptions, by using try and catch block. Okay. And one more thing, suppose here we specify the arithmetic exception. So this catch block will handle only if it is an arithmetic exception. Because if this statement is thrown some other type of exception, or null pointer exception, or array index out of bound exception, in those cases, this catch block will not handle, because we specify arithmetic exception here. So if the statement thrown null pointer exception, here it should be null pointer exception. If the statement thrown array index out of bound exception, here we should specify array index out of bound exception. So then only the catch block will be able to handle, otherwise not. Okay. So this is a simple example for handling the exception. So to handle the exception, what we have to do first? We have to identify the statements where exactly there is a chance of providing input from the user, and immediately where exactly that value you're using, this value we are using in this statement. So definitely there is a chance of providing an invalid input here. So we have to keep this in the try block, and immediately catch block will handle it. Just hold on, I will come to that part. Still we haven't completed the concept. Okay. So this is the first example. Very simple way we can handle arithmetic exception we have handled. Okay. Suppose you have identified some statements which will throw some exception, but you don't know what type of exception it will throw. Okay. You don't know what type of exception it throw. What I'm saying here is whatever exception this statement throw, the same type of exception name you have to specify in the catch block. Otherwise, it cannot handle. But suppose if you do not know what type of exception the statement will throw, then how can we handle? If you don't know which type of exception it is thrown, in that case, what type of exception we specify here, right? So here there are two approaches. If you don't know what type of exception that statement will throw, still we can handle in two different approaches. Okay. One approach is we can write multiple catch blocks. Okay. One try block can have n number of catch blocks. Remember this. One try block can have n number of catch blocks. After this catch, I can write another catch block. So in every catch block, you can write a different type of exceptions. And whichever exception is matching, that particular catch block will be executed. That is one approach. But there is a problem in that approach. I will tell you how to overcome that problem. First of all, let me tell you one example. Take a new class. Multiple catch blocks. Okay, multiple catch blocks. One single try block can have multiple catch blocks. Okay, so now let me show you how to write multiple catch blocks. So what I will do is I will write a simple code which will throw the exception. Let's say this is my code. I'm taking string values null. And after that, I will perform some operation on null. I can just find s.length. So this will give you null pointer exception, right? So when you print this, so this will obviously gives null pointer exception. But now I want to handle this. I can simply say program is finished. Okay, so when you run this, when you provide null here, it is simply giving null pointer exception. So now we need to handle. So this statement is not giving exception. This statement is giving exception because here it is taking input and here we are using that input. So this statement is throwing an exception, null pointer exception. Okay. So now what I will do is I will keep this statement in the try block. So I can just put try block. But suppose you don't know what type of exception this statement will throw. Okay, then what you can do? We can write on multiple catch blocks. So in the first catch block, you can write arithmetic exception variable. This one catch block and another catch block, catch. And here you can specify null pointer exception and variable. And even if it is not there, you can write another catch block. Here you can say number format exception E. So like this, you can write multiple catch blocks and here you can provide a message. Or if you want to print what type of exception that statement will throw, you can still print the type of exception. Simply what you can do is you can just print system.out.println. There is a variable called E, right? Arithmetic exception. So E dot That is an object reference variable actually. So there is a method, predefined method called get message. So this will give you the exception message. And after that, you can write a simple statement to the user. So user can provide here. I'm just saying handle exception or handle exception. Right. So I can put this in every catch block. So if you do not know exactly what type of exception this statement will throw, then you can still handle this by writing multiple catch blocks. But at a time, only one catch block will be executed. If the statement through an arithmetic exception, then first catch block will handle and rest two will ignore. And if the statement is through null pointer exception, then this catch block will execute, the first one and third one will ignore. And if the statement is through number format exception, then third catch block will execute. First two catch blocks will ignore. Okay, that's how it will work. Okay, now currently we are throwing, and if the statement is not throwing any exception, then all catch blocks will be ignored. Okay, now this statement is throwing null pointer exception. So obviously the second catch block should handle this. Okay, when I run this Java application, now observe handle exception. And which type of exception this is? Cannot invoke string.len because S is null. It is clearly giving the message. Why the exception comes, right? This message e.get message. This method is provided detailed information about the exception. And finally, program finished. So rest of the statements are got executed even though we got an exception. So this is how we can also write multiple catch blocks for one type of try block. One try can have a number of catch blocks. But there is a problem in this. Can anyone notice what is the limitation in this approach? What is the limitation? So if the statement is thrown exception, one of the catch block will handle that. You can write multiple catch blocks with a different type of exceptions. Okay, there is a problem in this approach. Yes. Suppose this statement is thrown any other type of exception other than these three. Because in Java, there are hundreds, thousands of exception types are there. So you mentioned only three types. Whatever the exceptions you know, you mentioned only those three types. But if the statement is thrown other than these three exception, anything else, some other type of exception, then still you have a chance of getting an exception. That is the limitation. And the second thing is your code is increasing, right? How many catch blocks you will write like this? If you write so many catch blocks, obviously the code will be increased unnecessarily, right? So that is another problem. But how can we solve this problem? If you don't know the exception, still you can solve the problem just by writing one catch block. With one catch block, can you handle this? How can we handle this? Instead of writing multiple catch blocks, you can just write only one catch block. Okay, one catch block. And normally what you will do here is specify the exception type, whichever exception the statement will throw. That exception type is specified, like arithmetic exception, null pointer exception, number of and so on. But here you just write only exception. That's it. Exception E. And this will handle all kinds of exceptions. This catch block will handle all kinds of exceptions. And you no need to write multiple catch blocks. You can just comment them. Multiple catch blocks are not needed. Just one single catch block, you can handle all types of exceptions. How it is possible? Because exception is a parent class of all other exception classes. This is a super class. Exception is a super class. All other number format exception, null pointer exception, all these exceptions classes are derived from one super class, which is exception. So that is the reason exception class will handle all kinds of exceptions. All kinds of exceptions. So if you do not know what type of exception you will get, simply you can write one single catch block and specify the exception. That's it. Okay. Now execute. So this will also handle any type of exception, arithmetic exception, number format, whichever exception you have here, this catch block, one single catch block will handle this. Okay. So understood everyone so far? What is an exception? What is a problem with exception? How to handle that exception? Okay. And how to use try and catch block, how to use try and multiple catch blocks. Now, let me show you something else. Try and catch block we use to handle the exceptions. Any type of exceptions, we have to use same kind of a block, try and catch block. And there is another additional block is also there that is optional. If you want to use, you can use it, or else you can ignore it. That is finally block. Get message exception. This get message will get the information why exception occurred. Okay. So if you run this code, that e.get message is giving this statement. This statement is given by this message, get message, this one. What it is saying, cannot invoke string.length because S is null. It's very clear, right? Because of S is null, we cannot apply any methods. Because S is null, there is no value in it, but still we are trying to apply the method. That's the reason exception comes. So the same reason it is giving here. The get message is part of this exception classes. Get message is available in these classes, and we can access it by using this object variable e.get message, like that. Okay, it is not exception. This is just a method, and which will print the details of the exception. This is a message. For every type of different type of exceptions, you will get a different type of message, because the same exception will not match with other type of operation, right? Yeah. Now, in the try catch block, in addition, we have another block called finally block. So first we will write try block, and whichever statement is throwing exception, we can keep those statements or statement. Immediately we will write one or more catch blocks. After that, we can write finally block. Finally, only one catch block is having this bracket, because we have to specify what type of exception it should catch. And finally block is always followed by catch block. Even if you have a multiple catch blocks, after completion of all the catch blocks, you can write finally block. Okay, so what is the use of finally block? So whichever statement is throwing exception, that we will keep inside the try block. And to handle the exception, we will keep the catch block. But why do we need finally block? Okay, so why do we need finally block? So finally block statements will always execute. Whether you get an exception or you may not get exception, in all the cases, finally block will always execute. Okay, suppose if the statements are executed, catch block is handled, exception, and finally block will execute. If the statements are executed, but there is no exception, catch block will ignore, but still finally block will execute. There are multiple cases are there. All cases, finally block will execute. In every case, finally block will execute. Okay, let me write all the cases here. Case 1, suppose exception is occurred. Catch block will handled. Still finally block will execute. Exception is occurred. Catch block is not handled. For example, exception is occurred, but catch block is not able to handle. Still finally block will execute. Exception doesn't occur. Obviously what happens? Catch block will not execute, but still finally block will execute. Means what? Finally block will always execute without depends on exception or not. Exception comes or exception not come, it doesn't matter. Finally block is always execute. Okay, but why we need to use finally block? This is the optional block. That's the reason they have not make it as a mandatory. When you write a catch block, when you write a try block, catch is mandatory block. But finally is an optional block. If you want to write, you can write, otherwise you can ignore. But what we can write finally block normally. So if you want to execute any statements without depending on exceptions, you can keep those statements in the finally block. Okay, suppose I want to execute. Suppose normally what happens is, in the real scenario, I'll tell you. When you're working with the databases, especially, or when you're working with the files, or when you're working with the databases, normally what happens is, we will create 3 blocks: try block, catch block, and then finally block. Just a second. Okay. So normally when you're working with the file concepts, or when you're working with the databases, we will write try block, and immediately we will write catch block, and finally block. So in the try block, we will write the piece of code which will establish the connection or open the file. Suppose I have some text file. Okay, I want to read this data from the text file. So before reading this, first our program should establish the connection to the file and open the connection. We have to open the file, right, to read the data. So for that, we have to write some piece of code. So that we will keep in the try block. Okay, suppose when you open the file, or when you're trying to connect to the file, and when you're trying to open the file doesn't have any data, or file itself is not found in that particular location. Still, there is a chance of getting an exception or not, right? File not found exception you will get. So that exception will be handled by the catch block. So this block will handle that exception. Handle exception. Okay. But in the finally block, what you will write? If in the try block, we open the file successfully, right? Then what we need to do after doing the operations on the file, once your job is done, then we have to close the file. We have to close the connection. So such type of code we will write in the finally. So closing connections, okay, and closing the files. So these type of code we will write in the finally block. This is the real scenario. Okay. So try block, we will keep all the statements whichever can throw the exceptions. Yes, you are right. Okay, and in the catch block, we will write which will basically handle that exception. And if finally block, we'll always use for opening and closing the connections of the files or database or whatever. That's the purpose of finally block. Okay. And if you're not opening any file, or if you're not opening any connections in the try block, you don't need to go with the finally block. You can simply write try catch block. Okay, this is the use case. I'm just example I'm going to tell you. But it is always optional. And it doesn't depend on anything, whether the exception comes or exception not come, or exception handle or exception not handle. It doesn't consider all those things. All the statements in the finally block will always execute. That's how they have designed. Okay, let's see one more example for finally block. And I told you 3 different cases, right? Exception is occurred, catch block handle, final block will execute. Same thing, final block will execute in every situation. Exception occurred or not occurred, handle or not handle, doesn't matter. Finally block will always execute. Right. So let's create another example with finally block. Try catch along with finally block. And in case if you have a multiple catch blocks, where you have to put finally block, after completion of all catch blocks, at the end you have to add finally block. Okay. Now finally block. Okay, so now I'm just showing one example for finally block. I'll copy this. Okay, so let me copy the same code and then I will show you how to work with the finally block. So this is your catch block. This is another statement. Where is the try block? This is a try block. Okay, so now let us look at this example. So here I'm taking S null. This will throw exception and catch block. So additionally, I will put one more finally block. In the finally block, you can write whatever you want. So I'm just writing a simple, you entered into finally block. I'm just writing a simple message. Okay, so here I'm writing more meaningful message. I can say when the catch block will execute, if any exception comes, catch block will execute. So here I say catch block handle, catch block handle exception. Okay, now just observe this. My first case, this exception, I'll put one valid data. So in that case, the statement will not throw any exception. Right, the first case, exception occurred, catch block handle. We'll see that. Exception occurred means if you have a null, so exception will occur and the catch block will handle. So here I will put null pointer exception. Because when you put exception, every exception will handle. So here I'm saying null pointer exception. Okay, so now this statement will throw exception, catch block will handle. After that, finally block will execute. Okay, just observe. Catch block is executed. Why? Because that statement is thrown exception. This is exception message. And you enter into the finally block. You can see the statement is executed from the finally block. So entered into the finally block. After that, program finished is executed. Okay. So like this, we can use finally block. So this is one case. Exception is occurred, handled, finally block is executed. First case. Now the second case, exception occurred, but catch block is not handled. Still finally block will execute. So exception is occurred, but when this catch block cannot handle, if it is another type of exception, let's say I'm saying number format exception. Number format exception. Now will it handle that exception? No. Catch block cannot handle that exception, but still finally block will execute. See here, try block, this statement throw exception. Exception is thrown, catch block is not handled. So exception message is got, but still finally block is got executed. See, finally block is got executed. Rest of the statement is got skipped. Because when the exception comes, the rest of the code will not be executed, right? But finally block will always execute. Even though the exception is occurred, finally block will execute. This is the second case. Suppose exception doesn't occur, catch block will obviously ignore. In that case also, finally will execute. For example, here I have taken welcome. So this will not throw any exception. So here I can say again null pointer exception. So this statement will not throw any exception. Obviously, catch block will ignore, but still finally block will execute. Okay, so entered into the finally block. Program got finished. So finally block is optional block. And this block will always execute. Whether you get an exception or not getting an exception, whether it is handled exception or not handled exception, doesn't matter. The finally block will always execute. This is the additional block which we can write after try and catch. Optional block means even though if you're not keeping this final block, you can still use only try catch block. But catch is mandatory block. When you write a try, we have to continue with the catch block. In between these two, we should not write anything else. After closing try block, immediately you have to start with the catch block. After that, finally block you have to write. If you have a multiple catch blocks, after completion of all the catch blocks, then we have to write a finally block. But we should not write finally block in the middle of this. Finally block always comes at the end of the catch blocks. Okay. So these are all about unchecked exceptions. Whatever exceptions so far we have discussed about are unchecked exceptions. Means we have to identify the scenarios and where exactly the user is providing invalid data. And accordingly, we have to keep those statements in the try-catch blocks and we have to handle the exceptions. This is our developer job. Now, we'll discuss about checked exceptions. Checked exceptions are very, very simple. But before going to checked exceptions, is it clear everyone? Unchecked exceptions. Unchecked exceptions are exceptions which are not identified by Java compiler. So we have to identify and we have to write try-catch block and we have to handle it. Such type of exceptions are called unchecked exceptions. Exception type can be anything, but the handle exception is the same way by using try-catch block. Okay. Now checked exceptions. And we will get very frequently checked exceptions while writing our automation code. Whenever you're trying to use some external classes, very frequently we will get checked exceptions because we don't need to bother about this because Java will intimate you. We can easily handle checked exceptions like interrupted exception, file not found exception, IO exception. These are all different examples of checked exceptions. And simply I'll show you one example. And anyway, coming sessions, we will see so many types of checked exceptions. Wherever it is getting checked exceptions, we will be able to handle it. But checked exceptions, we can handle in two different ways. We can use try-catch block. Also, we have to use throws keyword. There is one more keyword is there called throws. Okay, throws. By using this throws keyword, we can handle. So checked exceptions can be handled in two ways. So one is using try and block, try catch, that is common. And the other one is additionally throws keyword. But most of the times we use throws keyword. Okay, I will tell you why. So first, let me show you one example for checked exceptions, how Java compiler will identify that exception. See this. I'm closing this. I'm creating new class. Okay, this is checked exceptions. Okay, so in this, I'm just writing simple code, just observe. Okay, a program started, program is in progress. And after that, I will write two more statements. So 4 statements I have written. So when I execute this code, all 4 statements will execute at a time, one by one. If I look at here, immediately we got an output. So what I want to do is, once I print these 2 messages, after that, I will pass my code for some time here, few seconds. After that, I want to execute these 2 statements. Okay, once I executed first 2 statements, I will pass my code or I wait for something. And after that, after 5 seconds or 10 seconds, I will execute the rest of the statements. For that, in Java, we have a method, built-in method, which is there. Thread is a predefined class in which we have a method called sleep. Thread.sleep. In this, we can specify the time. How much time you want to wait here? How much time you want to pass your code? Let's say 5 seconds I want to pass. Means 5 milliseconds you have to provide. So this will take time in milliseconds. So 5 milliseconds equal to 5 seconds. So I put this method. So if you look at here, right? So thread.sleep. So the sleep is a method which is already there in the thread. and we are passing some data in this. So this method will wait here 5 seconds. After that, rest of the statements will be executed. But now if you look at this statement is giving some kind of an error. See, it is not an error actually. So in the Java, you can see these lines, red color lines in two different scenarios. One is if it is an error, if you miss semicolon, or if you use lowercase character instead of uppercase, or if you miss curly brace. In such case, you will see this kind of a cross mark error underline. In another is, suppose your code is perfectly written and some statement will throw some exception. That is already identified by Java. So in those cases also, it will give you error like this. So when you put like this cursor, it is saying unhandled exception type, interrupted exception. Unhandled exception type, interrupted exception. So this particular statement will throw interrupted exception. So Java is intimating us. This particular statement will throw interrupted exception. So Java is intimating us. So now what we need to do, we have to handle this. To handle this, what we can do, we can simply put this in the try block like this, and immediately we can write catch block. And what type of exception it will throw? Interrupted exception. That you can write interrupted exception E. I think this is a spelling mistake. So interrupted exception, this will throw. You can just put the cursor, you will know exactly what type of exception it will throw. So this is the type of exception. So you can keep in the try block. And here you don't need to remember the name of the exception also. It will clearly show you. So in the catch block, you can write interrupted exception E, and whatever you want, you can keep in this bracket. Okay, you can put like this, or you can put in the same line. If you don't want to write anything, you can just keep empty, no problem. Okay, this is how we can handle the checked exception by using try catch block as usual. So now I'm executing my code, just observe. First two statements are executed. After 5 seconds, then another two statements are executed. So this particular statement will throw interrupted exception. So Java is already notified that. So it is intimating us. So better to handle this exception. But what is interrupted exception? So this particular statement only throwing interrupted exception. So when you will get this is, let me tell you a scenario. Actually, this is related to memory management, multi-threading concept, but let me give you very high level overview. What is interrupted exception? See, what exactly this statement will do is thread.sleep. So whenever you start running your program, for example, you run your program. So once you run your program, some process will be created in the memory. Okay. Suppose if you have executed 5 programs, 5 different processes will run parallelly. And similarly, if you run one program, one process will run. So as soon as you executed your program, one process will be created. Processing in the memory, there will be some memory allocated, and in that memory, the process keeps running. Once the process is completed, then program will be exited automatically. So what this thread.sleep will do is, as soon as you run your program, the program is running. That means the process is running. And what exactly we are doing here? We are saying thread.sleep. Means this command will make this process sleep for some time. Okay. So 5 seconds we put. So 5 seconds, this first 2 statements will execute. After that, 5 seconds, it will pause. After that, it will resume, and then execution will start, and finally exit. So while this process is going on, suppose if any other program is running parallelly, that will also create another process, right? And this process may interrupt this particular process if you do not have enough memory. Okay. If you do not have enough memory, suppose there is some only same memory location, this process is running here, and immediately parallelly you run another program. But how, from where this program will get process memory? Again, it should allocate here itself. Then normally what happens? This is replaced by this. So once one process is running, another process may interrupt the existing process. So there is a chance of getting an exception. So that is the reason when I use this statement, thread.sleep, Java is intimating there is a chance of getting an exception, interrupted exception. So better to handle this. When you put try catch block, what happens? Even though some other processes interrupted this, still we will not get an exception. We will get exception, but we will be able to handle that exception. So that is the meaning of this. Okay, so we'll see other type of exceptions like file not found exception, IO exception. So many types of exceptions are there like this. So in the coming sessions, we will see so many exceptions. For now, just understand only this much. So these exceptions are already identified by Java itself. So we no need to bother how the Java is identified, all those things. So that is Java mechanism. Okay. Similarly, there are so many types of exception. For example, here I'm writing some different code. Or if you're not understood, don't worry. I'm just giving simple example. Let's say file input stream I'm using equal to new file input to stream. Okay, and the C drive somewhere I'm using text.txt, right? So I have written this statement. So the file input stream S is a capital. Okay, I'm just trying to import this. Okay, now just observe this statement. When you write what is the purpose of this statement is normally if you have any text file in your machine or Excel file or whatever file you have, before reading the file, you have to open the file in the reading mode. So this statement will basically open the file in the reading mode. Later, we will use this for reading purpose or writing purpose. So this is an object actually. File is representing the file object. So we are opening the file and that is represented with this file. So once you open the file, we can perform some operations on the file. So when you put this, when you see this statement, this is the external class. So we have to import this. But after that, it is still giving some kind of error. If you put the cursor here, what it is saying? Unhandled exception type, file not found exception. Java is intimating us, you may get file not found exception error, file not found exception in the runtime. You may get file not found exception. Java is identified this. Java is intimating us. But what is file not found exception? You are executing this statement perfectly fine. But at the time of executing this statement, if the file is not available in that location, right? If the file is not available in that location, is there any chance of getting an exception or not? Yes. So that is the reason Java is intimating us before itself. Maybe file is there, no problem. File if it's not there, you may get some exception. So please handle this. So that's how Java will identify. So immediately what you can do, we can put this statement in the try catch block. Okay. So this is simple example I'm telling you. If you're not understood this statement, no problem, I can leave. So how checked exceptions work, how Java will intimate you. So that's what I'm explaining here. So as I told you, checked exceptions we can handle two different ways. One is try catch block, we already know. And another one is by using throws keyword we can handle. So let me show you how to handle by using throws keyword. It's very, very easy. And most of the times we prefer that also. Instead of try catch block, we prefer always throws keyword. Let me comment this try catch block. Okay. Also comment this. Just observe. I'm writing again thread.sleep. And 5 seconds. So this will throw unchecked exceptions. So it will throw checked exceptions. Now, without using try catch block, how can we handle it? Put the cursor simply here. It will show you two suggestions. If you click on surround with the try catch directly, this will be added in the try catch block. This is the one approach, try catch block. Suppose if you have like this thread.sleep And if you want to add throws keyword, you can just put the cursor and select the first one here, add throws declaration. Once you click on it, just observe what will happen. Yeah. For the method level, there is one keyword automatically added, throws, and name of the exception. So this is another way. So at the method level, we can specify the exception. Throws interpret exception. So this statement will throw interpret exception. So that is added here. So this will also solve the problem. So when you run this, first two statements will execute, then thread.sleep will wait for 5 seconds. After that, rest of the code will be executed. By using throws keyword, we can handle. Suppose I have another statement in the program that also will throw another type of checked exception. Then how can we add here? So if you put the cursor, it will show you add throws declaration, right? Just click on it. See, another type of exception is got added. So like this, if you have n number of statements, no problem. Each statement is throwing different type of exceptions, still no problem. You can add all types of exceptions at the method level by using throws keyword. Throws interrupted exception, file not found exception, like this. You can keep adding more number of exceptions. Okay. By using try catch block, we can add exception. We can handle checked exception. Also by using throws keyword, we can handle checked exceptions. Okay. And try catch block is statement level. So whichever statement are throwing exception, we will keep those statement or statements in the try block. It is statement level. Throws keyword we will apply at method level. So in that particular method, whichever statement is throwing exception, that exception we will add to the method, corresponding method by using throws keyword. Okay. So what are the differences between checked exceptions or unchecked exceptions? Interview question. What is the difference between checked exceptions or unchecked exception? First difference. Checked exceptions are identified by Java compiler, whereas unchecked exceptions are not identified by Java compiler. Second difference. Checked exceptions can handle by using only try-catch block. Sorry, unchecked exceptions we can handle only with try-catch block. Checked exceptions we can handle by using try-catch block as well as by using throws keyword. And another difference. Try-catch block is statement level, throws keyword is a method level. Okay. So these are the differences you can just remember. Yes, just adding the exception to the main method, it applies to all through the program. Yes. So suppose if you write another thread or sleep. Okay. Same exception will applicable. Same interrupt exception is applicable for all the statements. Okay. Only one time we will add, that is only if you have one statement is applicable. If you have a multiple statements, we have only one keyword. Yes. For checked exceptions also, you can use exception class, no problem. Okay. So for example, this particular statement is throwing some exception, checked exception. Okay. And then in the try catch block, you can specify exception here. You can also specify the exception class. Okay. But it's not recommended try catch block, first of all, because as soon as you put the cursor here, it will clearly show you what type of exception it will throw. Just click on add throws declaration link, that will automatically add to the method. So this is the simplest process for handling checked exceptions. Most of the times we follow this approach. Only for unchecked exceptions, we have to take care our own self. But right, first identification is one thing. Once you identified, then we can put them in the try catch block. If it is unchecked exceptions, we have to take care. If it is checked exceptions, we can simply add this declaration because Java itself is clearly giving you the notifications. It is more simpler than checked exceptions. Okay. Clear, everyone? So this is all about exception handling concept. So this much is enough. Once you start automation, you will see so many types of exception. In automation specific, Selenium specific, there are some more exceptions are there. Element not found exception, element interactable exception, not interactable exception, stale element exception. So because they are purely related to automation type exceptions. Again, same way, handling the exceptions are exactly the similar by using try catch block. And if it is a checked exceptions, we can use throws keyword. Okay. So let us stop here. Just practice these concepts for today, and tomorrow we'll continue. So this is all about exception handling. Okay, so we'll stop here for today's session, and we'll continue tomorrow.